Pretty updated. But if you see anything that's off, let me know. Your tests I'll pass back to you at the end of class. Now, don't worry about, like, I know you guys talking about grades and whatnot. We'll worry about that when we get deeper in November. What was that? I have no idea. I have not calculated that. School only tells me for tests, not for overall grades, so I don't know. I'd have to compute that, but I'm not concerned about that right now. But we are a little behind because we did take a little bit of extra time with the previous unit. We had the calculator project, so we do have to speed things up a little bit. But the good news is that we did a very good review of factoring all these things on Monday. So it's kind of a lot of the same stuff. Yeah, Reggie, go ahead. It'll be on Friday. So we have plenty of time. So a great question. I'm going to get to that at the end of the notes today. So the test actually has been written, and actually I did work through it. It's already been written. Yeah, it's already all set. Yeah, I'm going to do that in a moment. Yeah, don't worry. Guys, let's get through this stuff first, because we have to learn stuff before we talk about the test, right? So anyway, so let's go, guys. Let's get started. So we're on 3.3. And the first question is asking you, are any of these three equations below equivalent? So really, this is all about simplifying, right? Simplifying is actually going to be the key focus of this unit. So that's why I'm not too concerned about speeding through it, because a lot of these problems are very similar to things you've done in the past, like factoring, simplifying, combining stuff. So let's take a look at the first equation. Can that be simplified? Yes or no? It can. How would you simplify it? Perfect. So you guys see how that would be an equivalent equation, right? Okay. How about the third one? What do you notice is common among all three of those terms? So what if I drop off the negatives? What do I get?
Y plus 2.
So these two are not equivalent. The first and third are not the same. Now let's look at the one in the middle. That one's kind of interesting because it's kind of complex. So it's a little complex. What do you think I could do about that second one? Yeah, I could also factor out an x. You see I pulled out the x from the left side? So yeah, you're tempted to FOIL the right side. I would say no, don't do that. And here's the reason why. Let me make a little space because I'm a little bit low on real estate. On the left side, what do they both have in common? Exactly. So I pulled it out. So see how like there's x, y, and 2x? I know it's not terribly obvious, but x, y, and 2x both have one in common, x. So I just pulled it out. Because what happens if I put the x back in? Do I get back to the same thing? You do. Remember, factoring is the opposite of distributing. If you distribute, you should be able to get the same thing as you did when you factored, right? So now what do you notice on each side? You notice something common. Can we drop them off?
Yes.
The only reason why you can cancel them out, x is being multiplied by y plus 2, and y plus 3 is also being multiplied by y plus 2. So when you cancel things out, it's the same thing as division. And what's the opposite of division? Exactly, right. So x is being multiplied by y plus 2. Y plus 3 is being multiplied by y plus 2. They can cancel out very cleanly like this. So now what do you get after you drop them off? So which two equations are identical? Second and third, exactly. Second and third. Those are the same. The second and third, 100% correct. Good. Okay. Second and third. Good. Okay. So it did require some algebra. Factoring. Actually, really just factoring. That's or simplifying, right? So hopefully that makes sense. How to handle that one. Okay. This next question is going to be on our test. There'll be a question designed very close to this. And you're asked, oh, Jaslyn, go, you have a question? No? Oh, I thought you had your hand raised. Sorry, my bad. Okay. Okay. Now, for some odd reason, I don't know why, but I'm going to try to do my best to teach this as best as I could. This particular topic, was really challenging for Algebra 2 last year. In fact, we had to reassess it 2 extra times after, and I'm not sure why. So not to freak you guys out, but the problems you see here are pretty much the problems that we'd have on the test. And I think what happens, I think it's all the letters, maybe all the letters freak people out. I'm not sure. So let's take it slow here. So let's look at part A. Y equals mx plus b. And you're asking to solve for the indicated variable. So they want you to solve for x. So what do you think that means when you want to solve for x? What does that mean? Get x by itself. Yeah, exactly. So where's x right now? On the right side. So what's connected to x? An m and a plus b. So let's think algebraically. How would I undo? Okay, that's good. But I would subtract first. And here's the reason why. It's going to be easier because if you divide right now, then you have to divide b by m as well. So let me show you an inefficient way first, and then show you a more efficient way afterwards. So yes, some people see this. I'll rewrite. Don't write this down. This is bad stuff. Don't do this. So some students will think, let's divide both sides by m. So they do this, right? Great. But then they'll write this. Do you guys see what I just did wrong right now? I made a huge mistake. Yeah, I think always, yeah. If this is getting divided by m, so does this too. You can't just think that this only gets divided by m, this doesn't. For example, what if I have 3 plus 4 divided by 3? If I were to ask you to work that out, what would you say the answer is? 7 or 3, perfect, thank you, Aiden. But you wouldn't say, well, let's cross off those 3s and say it's 4. You wouldn't do that, right? Because a 4 must also be divided by 3. If you so desire, you could then 3 over 3 plus 4 over 3. You still get 7/3. You could have done that if you wanted to. But it's much easier to add the 3 and 4 together and divide by 3. Now, unfortunately, we have letters because it's more abstract. Mx plus b, they can't combine. They're just mx plus b. So you could divide by m, but what happens is that then we make mistakes because then you forget to divide b by m. So I would much prefer that you subtract the b first. I'd much prefer that. Because then what do you get now? Y minus b equals mx. So notice how it's a little cleaner. And then one more step. What's the last step to get x by itself? And now you're done. So the entire left side gets divided by m, and that's it. But what happened was I had students that would divide by m first. I mean, then they were like just really confused and making all these errors. So let's be very clear what we need to do. We need to get x by itself or some other letter by itself. Let's go about the algebra in an easy way. Don't make it complicated for yourself. So for example, b, a equals pi times r raised to the second power. I'm going to kind of lay it out like this so you can really see what's happening on the right side. So what's our goal here? To get what by itself? Okay, good. What's connected to r right now? A pi and an exponent. So I probably should get rid of that pi first, right? So notice what I'm doing. I'm doing the reverse of PEMDAS in a way as I'm undoing it. Because yes, we do exponents for multiplication, but I'm actually dividing first to get rid of that pi. What happens? Those go away. A over pi equals r squared. Now, there's a square symbol. What's the opposite of squaring? Square rooting. Very good. So you do a square on each side, and guess what? What does r equal? The square root of all that junk. And now you have r isolated. Now, why do we care about this? This will be a big deal as we move on to pre-calculus, when we start doing trigonometry, and also in calculus. You have to be very adept at getting letters by themselves in order to do the more advanced stuff down the road. This is a skill set we have to develop, and it takes time. But as long as you're careful with your algebra, these are really not that bad. Some more good. Yeah, I'm gonna go. Yeah, D is a crazy one actually. I have the test in front of me, and we don't have one like D. D is a little much, but I'll do D with you guys for sure. But C is pretty reasonable. Now C is V. That's, by the way, this is volume, in case you're curious. Length times height times width. Okay. W. I want to get W by itself. What's connected to W right now on the right side? By what operation? What's optimal multiplication? So I'm going to simultaneously divide both sides by LH. Instead of doing individual, I'll just do LH together. Because guess what? They cancel on the right side, leaving it just plain old W on the left. Sorry, W on the right side. So it's V over LH. Also, this is a skill in science. I think some of you guys might be taking physics. Sometimes you have to isolate variables in physics or chemistry, perhaps, if you're doing with like gas laws or something. So it's just a skill that we want to have developed really well. Reg, you had a question? Okay, good. All right. Hey, D. D's a little crazy. What do you want to get by itself for D? Yeah, so I'm going to move the 2x over first. So let me clear my screen. I'm going to move the 2x over first. So 1 over y equals 3 minus 2x, right? Because I have to subtract 2x first to get it to the other side. You can do a couple things. One thing you could do is flip over both sides. I know it's kind of crazy, but you could raise both sides to an exponent. I know that's not obvious, but you can do that. Because if you do the one side, and you do it to the other side, it's fair treatment. What happens when I flip the left side? What does that become? But the side, the left side, y, and then the other side is 1 over that junk. And guess what? It's isolated. So that's kind of a nifty technique you're allowed to do. It's not obvious to do it because you're just learning about negative exponents, but you can do that as long as you do it to each side the right way. Another way you could have done it too, I'll do it down below because I'm out of space. When I was at this point here, if you don't see fractions, assume you have a fraction. By the way, anything can be a fraction. What do you put below it?
1.
1. Anything can be a fraction. Any number, any expression. If it doesn't look like a fraction, just force the issue. Now, what if I cross multiply? I have 1 times 1 equals y times 3 minus 2x. Now, I can move the 3 minus 2x to the other side by dividing by it, and I still get the same thing, because 1 times 1 is 1, obviously. Divide by 3 minus 2x, you still get the same thing. So it's a little bit more like brain surgery in some ways. You have to kind of, there's a lot of moving parts. But personally, if you have a fraction where you could flip it, I would do that by raising it to -1 and just got to flip the other side too. So either way, we'll get the same result as long as I'm doing my algebra correctly. But I will acknowledge D is more abstract. D is more challenging. It's not as obvious. We won't do one like D on the test because you guys are still learning this skill. But I want to show you kind of a variety of difficulty levels of these. But I say A, B, and C are more manageable. Charlotte, go ahead. Mhm. Oh, yes. So, what I'm going to do is I'm still going to have old stuff because I have to make sure that. So that when I put old stuff on the test, it's not just for retake purposes. It's also just to make sure you're reviewing old stuff. Because come like December after Thanksgiving break, it's gonna be a whirlwind because you're gonna have Christmas course and you have like all the finals and all these projects. So yes, we're gonna there'll be 2 questions on the upcoming test. They'll be on graphing. I'm gonna tell you guys what to expect. Yeah, so you know what to study. Yeah, but you're not gonna have the retake because you did well. But it's just good to review. So yeah, Aiden, go ahead. 2 unit tests and the final exam. So essentially 54% has pretty much been determined of your grade. 46% remains, which is each of the 2 tests are 13% each, and the final exam is 20%. So still about a little less than half of the grade is still yet to be determined. That's why you guys still have a lot of room for growth. We could go ahead. Yeah.
Why isn't it 2x plus 1 over 3 is y? Because when we divide like 2x plus 1 by 3.
Okay, but the thing is that 2x is 2x over 1. Doesn't have the same denominator as 1 over y. If you want to do that, you could do that if you want, but then here's what's going to happen. You're gonna have to if you make it 2x over 1, you have to multiply top and bottom by y and y in order to combine with the 1 over y. You can't combine it unless they're the same denominator. But I wouldn't do that because it makes it messier. Or are you saying combine the left side, like make it 2x plus 1 over y? Are you saying that?
I multiplied by y first.
Oh,
put it to the other side.
oh, I see what you're saying. So you're doing this. You're doing this first? Do you do that?
No, I'm doing like 3y equals 2x plus 1.
Oh, I see what you're saying. So you multiply. Okay. Yes. I'm glad you brought that up because a lot of people made this mistake too. We had a question that was kind of like this in one of our tests. Okay. So you multiply both sides by y, right? Is that what you're trying to do? Yeah. Okay. Here's the deal. The 2x must also be multiplied by y.
Oh, got it.
Yeah. See, that's what happens again. People forget to do these things and they run into mistakes. See, it's the same thing. Like, what if I have like 3 plus 4 equals, okay, well, obviously 3 plus 4 equals 7. Okay. I don't know why I'm bringing this problem up. I multiply both sides by 2, right? The 2 has to distribute to both. So it's, even if you see letters, it's no different than true with numbers. It's no different. Okay, let's look at 3.
But if it's multiplication, like if it was 2x.
Oh, in that case, then you're fine. Yes. Yeah, because it's all combined by multiplication, right? So it just depends what you're given. All right, now next up, for 3. These look pretty wacky, right? But can we simplify? Kosamar, what are you gonna say? Yes, good. Every single thing gets divided by 100. So see how it becomes this now? And it's fair treatment because you're doing it to every equation. Sorry, to every term. Sorry, don't mix up my terms, my vocab. Every single term, 100x squared, 100x, 2000. Each one gets divided by 100. So if I move things over to one side, what do you get? Something you can easily factor. And we talked about factoring last time, right? See, I made this a much easier problem by simplifying. And that's what we're trying to teach you guys. This is the takeaway from CPM, this particular unit. This particular unit is trying to help you make your life easier when you do math. What happens is that you get stuck in these old techniques, these old habits. They're hard to snap out of. And that's why we make mistakes, because you don't think to do these more efficient ways because you're just relying on what you've done in the past, right? In the past, what have you done before? You would subtract 2000 and then you think, okay, well, I had some crazy stuff here. I think hopefully you would see the fact of 100, but let's just get the 100 out of the way first to make the problem easier for ourselves. Does that make sense for part A, how I did it? How I divide by 100 and made the problem easier? Now let's look at part B. At fractions. Fractions are scary. And I also have to acknowledge and accept the fact that, hey, 4 or 5 years ago, there was a pandemic and fractions were a big part of whatever you guys are doing 4 or 5 years ago. And unfortunately, someone's trying to teach that to you over Zoom, which sucks, right? It was terrible. You guys are not connected, with the teacher in the class, right? So let's get over our phobia of fractions and let's make this easier for ourselves. What fractions, what denominators do you see right now? 2 and 3. What's the least common denominator here? So it's 6. So wouldn't it be much easier if I multiply everything by 6? Right? What if I multiplied every single fraction by 6? Like, for example, what's 6 times 1/3? 2, yeah. What's 6 times x over 2? Yeah. That's not that hard. What's 6 times 1/3? 2 again. Okay. Now we're rolling. 6 over 3, 2x squared. 6 over 2, 3x. 6 minus 1/3, -2. And by the way, we will let you use a graphing calculator for a question like this. So you could just graph this and find the x-intercepts. Of course, I'm going to ask you to factor it, but at least you can have that validation of like, hey, let me graph this equation, see what the x-intercepts are. Heck, you guys have a quad form program, right? So you can punch in your program. It'll give you the answers, right? So you'll be able to get it pretty fast. But I still have to see the factoring. I'm going to just get a little more efficient here. I'm just going to just kind of do this in my head. Mind you, there's other techniques for factoring that you could do to help out. Do you guys see how this would break apart? If I do 2x and x, what would go with those? What do you think will make sense? Because -2 can only break apart as a couple ways, -1 or 2 or 1 or -2. So in this case, I'll probably want to put I know what you're saying. So probably I'll put a +2 here. You get 4x and a -1 here. Does that work itself out by FOIL? Yeah. I get -x and 2x, which is 3x. Good. Okay. What will each of these equal if I said each of these equal to 0? X would equal what or what? How about the first factor, 2x minus 1? What would make that 0 and then on the inside? 2x minus 1 equals 0. Solve for x. What do you got? 1/2. Good. How about for the second one? Negative. There you go. Those are your answers. That's it. So you can trust me. I've seen people do some really weird stuff over the years. I'm like, whoa, like things that they did that I was like, I didn't even know you can make that kind of mistake. Like just really kind of interesting misconceptions. But we want to avoid that. We want to be efficient, and we're going to practice these skills over the next few class meetings. Okay, let's keep moving. Okay, we'll do a couple more here, and then we'll have to move on to the next set of notes because we have to, speed things up here. What's the common denominator here? This is kind of tricky. First of all, what are each of my denominators? The first fraction is what? X squared. What's the second denominator? What's the third denominator? If you don't see one, you see one, right? So if you think about it, is x a factor of x squared? Yeah. Is 1 a factor of x squared? Yeah. 1's a factor of anything. So what you can do is you can make your common denominator x squared. Because guess what? If I multiply each fraction by that, it's going to come out really nice and clean. So here's what I'm going to do. I rewrote the equation. So you see what I'm doing? I'm doing the same thing on each side. There's no harm, no foul. As long as you do one thing on one side, you do it to the other side, right? It's balanced. It's fair treatment. So if I multiply everything on the left side by x squared and multiply everything on the right side by x squared, it's all good. Let's look at the right side. If you have 0 times something, what do you get on the right side? Just 0. Yeah, you guys know that. Good. Yeah, you guys know. So that's 0. Okay, now, very careful. This x squared has to get multiplied to each fraction. So it's going to look like this. X squared times 4 over x squared plus x squared times 12 over x plus x squared times 9 over 1. Want to get good with this, you'll write it in a more efficient way. But for now, I have to kind of be more detailed so you guys see exactly mechanically what's happening. So we're lifting up the hood. We're trying to see like everything that's going on so we feel comfortable. This gets multiplied. This gets multiplied. This gets multiplied. Fair treatment. Now, look at this over here. X squared times 4 of x. So what can happen with x squares? Yeah, exactly. X squared over x. What happens? Cancel again, yes. And then that just becomes what? 9 x squared. Yes, good. So you get 4 plus 12x plus 9x squared equals 0. I know you guys can solve this because we did it in the last class. Or you have your calculator. You have the quad form program calculator. I could check your codes again, make sure you guys they're not messed up and they still work fine. Granted, I still need to see the factoring, but if you plug in your calculator, like I'll show you right now. Actually, I don't have the program. Actually, I should actually type it up in the calculator I have here. Give me one moment. Let me locate it. Let's see. We go till 11:30. Fuck, got plenty of time here. We're good. Okay. Let me clear the screen here. Sorry. Okay, let me clear screen. All right, so I don't have the program, unfortunately, but what if I did 9x squared? And was it plus 12x, guys, right? Plus 4, okay. The graph, okay, let's graph it. It's a parabola, right? Okay, it's hard to tell. So let me zoom in a tad. Okay, where do you think it's touching? It's kind of hard to tell, but where do you think it's going to be touching? Well, that's -1. That's -1 right here. So it's probably a little bit greater than -1. It's not going to be terribly obvious, but if I get a little closer, yeah, it looks like it's going to be well, actually, go say Eloise. What was your you said actually close. Flip it. You did 3/2. It's gonna be -2/3. If you flip it, yeah, you see you gotta do the reciprocal. So it looks like it's 0.6 something. So we know we have a general idea of where it's gonna be. So let me get rid of some stuff here. because I still need you guys to, but and your quad form program is going to be way more accurate. It's actually going to give you a much better answer. But we can factor this. We've done it already. 3x plus 2. 3x plus 2. We talked about this. So if that equals 0, what does x equal? Subtract the 2, divide the 3, which is negative 0.666 repeating. So the graph confirms it, and we confirmed algebraically. Now we feel better about our answer. Or if you have the quad form program, same thing. You'll probably say negative 0.6 repeating, and you're good. You get it. So hopefully that makes sense. Cool with that? Okay. Let's look at another one. Let's look at B, and then we'll finish off with number 5. Okay. For B, okay, what are my different denominators? I have x. What a denominator, denominator do I see here? X minus 1, yeah. And I see another x as well. So these are my 3 denominators, okay? Now let me ask this question. Is x a factor of x minus 1? No, right? I can't factor, x minus 1 can't factor anything out of it. When you have 2 completely different factors, you combine them as your common denominator. So your common denominator is going to be x times x minus 1. With the x minus 1 in parentheses. That's your common denominator. So what you're going to do, I'm going to lay it out very nicely here. And I'm going to multiply both sides by my common denominator, which is going to be x. If you guys can read that one on the right side. Okay, so I'm doing the same thing on each side. Now, let me rewrite one more time. This is the fun part. We'll do this in red. Okay. So this group, I get multiplied every single fraction or term, or whatever you want to call it. This gets multiplied by this. This gets multiplied by this. This gets multiplied by this. Let's look at this first set here. What cancels here? X. What cancels here?
X minus 1.
And what cancels here?
X.
X. There we go. So lots of canceling. Cancel, 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 cancel. So you have x minus 1 times x minus 3. This is definitely a more advanced question. Got a test in front of me here. Something not quite this complex, but you'd want to do something kind of like this, where you want to find the common denominator and multiply every fraction by it. Okay, so far you guys are with me? It makes sense what I did. So what I did was I decided to find the common denominator for all fractions, multiply every fraction by that, but I didn't change the denominators. What I'm just doing is I'm trying to actually get rid of the denominators by multiplying each fraction by that expression, the expression being x times x minus 1. Things cancel nicely as long as you do it correctly. And then we have to solve after that. So there's a little bit of legwork that's involved here to get this process moving. So now let me move this because I need a little more space here. But this is definitely a more advanced problem because now it becomes a new problem that involves foiling and more factoring. Okay, how would you combine this here? What do you guys say?
Foil it.
Yeah, but what would happen after I foil it? You get x times x, negative x, negative 3x, plus 3, plus 2x equals, and keep going, 5x, negative 5, negative x squared, plus x. Combine like terms. Yes, you guys have done that many times before. And let's see here. Negative x squared plus 6x. Notice you have to be incredibly organized in your approach. Very methodical. You know, clean up each side. And then choose which side you want to move everything to. I'll move everything right to left. So if I do that correctly, I'm going to add x squared to both sides. Subtract 6x. And add 5. So fair treatment, doing the both sides, right? So if we do it correctly, you should wind up with this. 2x squared minus 8x plus 8 equals 0. Then I could factor or divide by 2. So you should get x squared minus 4x plus 4 equals 0. Okay, this is crazy. And I think what I like to do, just to be mindful of not overwhelming you guys with too much stuff, after I finish this, we can start working on homework. I won't add another lesson right today because I think that's a little too much for you guys. Because I think you guys need to work on this. So I'm kind of calling it audible here. Because it might be a little much. How do I factor that bottom part? But before I do that, question I've done so far. Are you guys cool with the foiling? You cool with this over here, and then combine things, moving everything on one side. It ain't going to be very methodical. You know, just organizing your thoughts really well. At this point, we factor the bottom part. So let me get rid of some stuff here. Let's move it up. How do I factor that? You guys should know. What multiplies the 4 has with -4? Yep, -2, -2. So x equals 2. That's your answer. Now, how do you validate this in the graphing calculator? Simple. Very simple. You graph each side and see where they touch. So I could do parentheses x minus 3 over x plus 2 parentheses x minus 1. Make sure you put parentheses around any expression so it's protected. And then parentheses 5 minus x divided by x. Graph it, see where they touch. You can get some wacky stuff here. Okay, so it looks like it intersects somewhere over here. Hit second trace, option 5, and move close to it. Hit enter a few times. Okay, so where do they touch, guys? X equals 2. It doesn't say 2 exactly, but so I feel good about this. I feel like, yeah, I'm getting the answer here. Like, because I got it algebraically, that's what the graph shows. So you could use, and we'll practice this skill on Friday, because I think you guys really need some, practice that. All right, last one, and then we'll let you guys work on the homework, and then we'll yeah, I won't do 3, 4. 3, 4 is pretty simple. I could save that for Friday. It's fine. Excuse me, this one here. Let's find the LCDs. Okay, what 2 denominators do you see for A? So XY is your LCD. You multiply it out. And I'm just going to kind of just write the other ones so you can see the pattern. You're simply just multiplying together. That's all. As long as they don't share any factors. Like x minus 1, x plus 2. I can't factor anything out of them, so you just multiply it out. X are 2 different letters. That's why. X and x minus 5. X is not a factor of x minus 5, right? X minus 5 is what it is. So those are your common denominators. Okay. So homework will be really simple. If you go to the packet, the homework packet, it's going to say 3.3 on it, or homework number 21. So you have a bunch of problems here to practice. Don't worry about the extra practice problems. That's like, so it's really just the first couple pages. So pretty straightforward. It's just going to be, looks like 6 problems. So you guys get a head start on that now. You have about 20 minutes. Now, if you guys are curious about what I'm going to put on the test, that you could kind of just, I'll still tell you guys next week, don't worry. But in case you guys are curious, on our next test, what to expect. I'm recording this too, by the way. So there'll be recording. So this is all being recorded. There are two parts. It's going to be 50 points, like the last test. Part one will be 12 points. Part two will be 38 points. For part one, it's simply going to be 2 questions. Both are graphing. And it could be any of the following. It could be an x squared, an x cubed, a square root of x, absolute value of x, a 1 over x. So it could be any of those three with transformations.
See?
Yes, exactly. Yes. Same thing we had in the last test. Yes, 100%. The reason why we're doing this, we don't want you guys to forget.
So it's just a retesting portion, or is it?
It will count as a retesting portion, which probably won't apply to most of you guys because most of you guys did above 80%. But we can't have you guys forget this stuff. Okay, that's gonna be part one. There'll be 2 questions. They're graphing. Could be any of those 6 types of functions with transformations, like maybe it's like a x minus 2 or x plus 2 or some number on the outside. State domain range, state asymptotes. So yeah. And I'll say this as a PDF as well as a screen capture. So that's what part one will be like. There'll be 2 questions, both graphing, and we'll make sure we'll practice this. I'll try to have stuff ready by Friday, so you guys can go ahead and start studying for it. Now, part two of next week. Okay, part two. It's going to be, let's see here. Yeah, parts. Yes, so part one was no calc. Sorry. Yeah, that was non-calc, which is hopefully that was obvious because it's graphing, right? So, okay, part two. That'll be calc. There will be trying to think, how do I label this? Combine combine algebraic fractions. I'm going to call it that for you guys right now because I think that makes more sense. So it's something like that, combining algebraic fractions. Next one will be the state. So when the denominator equals 0, that's a problem, obviously, right? So we're going to ask, like, hey, state the excluded values. That's what's meant by that, because we're dealing with a lot of fractions in this unit. Next up is going to be solve for an indicated letter. We already just talked about that.
there be any stuff like 2 minutes ago?
Nope. I'm being completely transparent with you guys. Nope. So solve for an indicated letter. We just talked about that. That's like let me look at the notes again. About that. Let's see here. That's gonna be like example. Geez, these notes are so large. Like example 2. Of today's notes. There's gonna be something involved multiply and divide. Algebraic fractions. You'll see what I mean by that by tomorrow. Not tomorrow, sorry, Friday. And that's going to involve heavy factoring. There's heavy factoring involved with that. And let's see here. Oh, and then last one. Solve equations with algebraic fractions. Just like we did today. And that's going to be, that was examples what? Like examples 3 and 4. So what I will do is that from the notes, because the notes are pretty heavy, if I feel some notes are not quite relevant to these topics, I'm going to chop them off so we can get through the notes. Because I want to make sure I give you guys stuff that's relevant. Like examples 3 or 4 of today's notes. I'm going to repeat this next week as well. Don't worry. But it's an incredibly straightforward test. Now, I will be more transparent. I did work through the test. Anyone want to guess how long it took me to do the test?
6 minutes.
5.
8.
About 5 minutes. Yeah. So the point being, it's a very straightforward test. No word problems. No word problems. Okay. Hopefully that puts you guys at ease a little bit. It's but you'll get an hour still. Right. Yeah. So combined algebraic, yeah. So that's going to be and when I say combined algebraic fractions, what that really means is simplify. So I'm going to make sure that we really keep this as our focus for this unit. So, okay. So you guys can use the rest of class, excuse me, use the rest of class to work, or you could, if you need to relax for lunch, that's totally fine too. Or sorry, you still have another class for lunch, right? Oh, we have lunch after this?
Yeah.
We do have lunch after this. That's good. That's right. Forgot. Okay. That's right. We do. All right. I'll stop. Yes. Pass back test. Yes. No problem.